Hello, this is Jason Kozer's video on mastering regression. So first off, what is for you one single most important thing for regression analysis? I really like that when you get a model, it might look statistically significant, but you really have to understand it before you can trust it. It's not enough to just look at the coefficients and, you know, it's got a good R squared, so you take it. You know, you gotta understand the assumptions behind the data. You gotta understand how the predictors relate to each other, how they relate to the response. You gotta understand collinearity, and then you gotta potentially do some tests here and there to see if you can actually trust the statistics that you are looking at. And throughout this course, I started with a slight understanding of regression analysis. I knew what it was, but I haven't really used it before, and now I understand the different kinds, or a few different kinds, and like how to use them, how to like what you need to know to trust them. So I guess that's the analysis of them, and I think it's really important now that I understand more of just like I can't like in my future I can't just like look at some stats or some model that tells me something and just trust it. I want to look a little deeper to figure out, what's really going on with the data, so I know if it's trustworthy or not, and I really like that part of regression analysis. So one key insight from the theory, I thought it was pretty interesting that the fitted values, when it came to the, let me pull it up so I remember what I'm talking about. So when we're talking about the ridge regularization, the part where the geometric interpretation of the ridge constraint when it's adding, that bias and shrinking the coefficients, I looked it up and I thought it was pretty interesting. I hope I understood it correctly, that it's kind of like if you take the, like if you have p predictors and you take the p dimension coefficient space, it kind of like shrinks all of those into like a sphere. I mean, it wouldn't be a sphere if you have more than 3 dimensions, or I guess not 3 dimensions, but that idea, and it like shrinks them down to that radius depending on the lambda. I thought that was pretty interesting. And then for the applied work, I thought the norm part where you got random data from standard normal distribution was pretty cool. For some reason, for me, when I ran it the first time, I got like a very significant model, and then when I ran it for the 10 simulations, they were a little more to be expected. I mean, 2 of them seemed alright, but nothing like my first one. I'm not really sure. I thought I did everything the same. Maybe that's just random chance, but like that's the whole point. I thought it was really cool that, and it kind of makes sense when you get like a bunch of models, and you're just looking for the best one. You're gonna find one that has a pattern, because that's what the best one comes from. And then my champion model was AIC, and the the Bayesian model from the selection. They had the same thing, and I mean that kind of makes sense, especially with the AIC, because they just add more predictors to try to get a slightly better score, and we were just looking at the adjusted R squared for the best one. So I feel like it's kind of normal that it would beat out BIC in that situation. Um, Now, as for more challenging peaks that I still have to get over, uh, I would say that when we get to like the dimensionality and there's like it's a lot to think of, especially when I get into the math. Um, and then when multicollinearity is like with more than just like with data that I don't understand is kind of a little harder to wrap my head around. Um, I think that's all kind of just like if I worked more in this in the future, um, which I'm not sure if I will, but if I do, I feel like I'll get better at that. Um, but it has been fun to learn these different kinds of uh, regressions, and I thought it was really fun to do the model selection because you get a good model, but like when you have all these predictors, I like seeing which ones end up. Like you could think which ones are the best. Like for example, in the first part, I thought glucose levels were going to be a good predictor, but they ended up not being. And I think that's cool that you can, take some data and it'll tell you what predictors will give you the best prediction of your response. You start to learn more about what's actually going on. Now, as for my score for this assignment, I think I did pretty good. Maybe an A, maybe a B, somewhere around there. I did all the work. I put in my best effort. Um, I think I got. I think I did everything. I think I did everything right. But like I said for the last one, I had a little confusing results. Not sure what ended up going on there, but I think I did it right. And then, how has regression changed the way I see data in the world? I mean, like I said at the first point, you gotta understand how the data relates to each other before you can trust it. And I think that's a good conclusion to end it on. Thank you.